All right, hey, how's everyone going?
Good. How are you?
Cool, good. A little hectic. That's okay.
Yeah, you and Azad run the program there, right? So you probably got a lot of stuff going on.
It's mostly Azad. He he does all the real hard work, and I mostly have the luxury of just showing up and teaching and grading and advising. So he's extra hectic. But yeah, first week is always a little intense. All right. Any questions?
Okay, I do actually have a quick question about shell scripting and all that.
Okay.
So, can you make a so obviously push is a command. Can you turn a shell script into something called push that just runs that command as well as pushing everything to origin master and all that kind of stuff?
Yeah. So the command from Git is actually git push. So if you made a script called push, that could include the command git push. That would be totally fine.
Okay.
If
So
you want to,
as long as you don't say git in there, then it'll run the program push, which will be all your
correct.
commands.
Yep.
Okay.
Yeah.
Is there any names that are like off limits? Is there any commands that are
Yeah. There's lots of them. So test, for example, is a built-in keyword. PWD may be a built-in keyword. It kind of depends what version of the shell you have and so on and so forth. But anything that's already recognized by Linux, it's probably good to avoid. Test is the one that most people get in trouble with, because test means something different to Linux. But your ODPs, if you call them ODP something, you're pretty safe. And you can always test, right? You can always just put something in the beginning of your script that just prints a message and exits, and then you can see if that's going to work as a script name.
so it won't override a command, it'll just do the command.
Yeah, so for example, if I made a file called
Steven, is there a child in the movie going off, or is that my Zoom call?
I hear it too, but it's not me.
Sorry, my kid's sitting next to me. I'm trying to stay muted.
That's okay. So if I make a file called ls in my directory, right? Then when I say ls, it says ha ha ha, right? And now when I say ls, it says ha ha ha, you are funny, right? And that's not the ls command that we're used to. That's a script I wrote that happens to be called ls. So what can I do with that? I can say, where is ls?
Circles are definitely at the bottom.
Sorry? I can say, where is ls? And I can see, oh, ls, the command is actually /bin. So if I do /bin/ls, that's the ls command I'm used to. So you can get a little tripped up like that, but it's usually not a big deal.
Okay, so at that point you would just write the /bin and that pretty much brings your command back.
Yeah, so you haven't destroyed the command, you've just written something that runs instead of that command.
I mean, technically he could have been, couldn't he? Since he was in the back of the row, they would be the first to get off.
Hold on, we got two microphones open.
Okay.
Let me go ahead and mute everybody, and then if you want to talk, go ahead and unmute.
So it's kind of like key binding. You're just, instead of having a quick command, you're just rebinding it to something else that you wrote.
Yeah, exactly.
You can still use the ls. Okay.
Exactly. All right. So, couple of announcements. So, first announcements. I'm not going to have office hours this coming Monday. So I'll be at the dentist at 8 o'clock Monday morning. So no office hours this Monday, but they'll resume after that as usual. And I have a scheduled meeting with someone. I'll write them directly and reschedule Monday morning office hours. Second announcement. So I've been asked to read the following announcement for this class, which is as follows. This is a request for a volunteer note taker. So the announcement is the following. A student in this class has a documented disability that impacts his or her ability to take comprehensive lecture notes. We're requesting that someone, preferably two of you, volunteer to share notes. And so if anybody is willing and able to do that, please send me an email. And I posted an announcement on Canvas yesterday with my email address in there and this exact same information. Send me an email if you think you can do that, and it's pretty easy to get your notes to somebody else, and then it helps them out, and it's greatly appreciated. So shoot me a note if that's something that you think you can do, or you want to know more information about what's involved. All right, the other announcement was something that I posted in Canvas yesterday. So a lot of people were having issues with ODP 402 and with homework 2, so the GitLab stuff. And I'm seeing some talk in the chat window about GitLab issues around the keygen command. This is a good point to mention that computer science is probably about the pickiest of all disciplines you could choose to study, right? So medicine, where you're dealing with life and death, if you're supposed to, hang an IV bag with 60 milliliters of fluid in it, and you hang an IV bag and it has 59.8 milliliters, it's not going to make any difference, right? There's tons of wiggle room. Biology tends to be forgiving, If you're doing chemistry and you're supposed to use, 3 milliliters of something in a solution and you use 3.1 milliliters, it's not going to make any difference usually, right? Computer science is super unforgiving, right? If you put a period instead of a comma, your rocket blows up on the launch pad. Right? These things happen once in a while. And it's because computers are not forgiving at all. They will do exactly what they're told to do. They won't say, I don't know if that's a really good idea there, So computers do exactly what you tell them to do. And, you miss a semicolon at the end of one statement or something like that. And yeah, the magic genie, as someone said, will do what you told it to do. And if we're lucky, we'll try to compile code that has a mistake in it, and it'll say, oh, there's a syntax error. If we're really unlucky, it will compile a code and do what it thinks we told it to do, right? Well, what we told it to do, but what it thinks we wanted it to do. And so this is a discipline where it's really, really important to be able to do things like proofread, right? Or follow instructions to the letter. So I had 60-some emails yesterday from students having troubles with Git, having troubles with the ODP, and so on. And in almost every case, the issue was something that was already spelled out in writing in, the how-to or in the assignment or something like that. The trick is, as humans, we're not good with details, right? This is universal. And if you have a set of instructions, here's how you're supposed to set up your Git repository, and you're following those, you might not be following it exactly. You might forget the .git at the end of CSE224. You might skip a step. You might miss a pair of double quotes around something. And what makes it extra hard is that we are creatures of habit. We can look at those instructions and we can look at what we did 20 times and be absolutely convinced we followed those instructions exactly. because each time we looked at what we did, we didn't actually see what we did. We saw what we meant to do. You know, I meant to type in this line. Yeah, that's what I typed. I don't see what the problem is, right? So this is a challenge, and this will come up again and again in computer science. This comes up with debugging code, right? You've written a piece of code that's supposed to do something, and it doesn't work. And you stare at it, and it's like, I said do this, and I said do that, and I said do this other thing. Why doesn't it work? And a lot of times it's because you're not seeing the code that you wrote. You're seeing the code that you think you wrote. And so here's what I call the hardest bug of all in C programming. Right? And there's a huge error in this code, most likely. Right? What I want to do is check the value of a variable x, and if it's equal to 0, I want to do a bunch of stuff. But what's wrong with this code as I wrote it? Where's the bug? And I'm telling you that there is a bug here.
X equals 0, it needs to be equal.
Yeah, this needs to be equal.
Setting x to 0, and that's not really good.
Yep. And this is very good. And this is really hard to find, right? Now, when I write it down on paper and I tell you there's a bug, right? But if this is in the middle of 100 lines of code, and you've been working on this for 7 hours, and you're pretty sure that x is not equal to 0, but for some reason it's still executing these instructions here, right? And you're working on all this other code to figure out why x is equal to 0, right? And this is setting x equal to 0, right? And then it's saying, okay, so x is equal to 0, while 0 is false, so it's skipping all of these instructions, right? And this will, you know, at some point in most people's careers, this will cost some X number of hours of staring at their code before they find it, right? Because every time that I look at this code, I don't see a single equal sign. I see if X has the value 0, do these things. So this is something you're going to encounter again and again throughout this course, the sequence, university, career, and so on. This question of how do you look at something with fresh eyes, right? And so this was a lot of what people ran into on ODP 402 and on the homework. And it's okay, right? It's part of being human. This is how our brains work. But it's something to be aware of. And if you can't find a bug or you can't get something to work even though you follow the instructions, try taking a break, try stepping away, try coming back at it and starting from scratch, right? Pretend that you haven't already done this and look at it in a different light. Take the assignment you're reading, put it somewhere else, put it on the right side of your desk, put it on a different part of your screen, something, right? Put it in a different font. All right, so that was just a general comment. All right, let's talk about ODP 403. And let me show you ODP 402 first of all. All right, so this is a successful version of ODP 402. Basically 2 lines of bash, right? Read a variable, you can call it whatever you want, and then echo 2 times that variable. All right, so the most common situation people got in trouble was they were saying something like, you know, echo quote enter a number. Or at the output they were saying echo quote the answer is $paren, etc., right? And the assess program is humorless. It's unimaginative. It needs exactly what the assignment asks for. If I print out anything else in here, it's going to give me 0 out of 10, right? And so in most cases, people were echoing extra things and getting rid of those gave you 10 out of 10 on each test. So yeah, assess is a cruel program. On the other hand, right, the programming assignments that you're turning in to me, the longer ones, PA1, which we're going to talk about today and stuff, within, you know, pretty loose bounds, you should feel free to explore the design space with those, right? So if you want to have, a talking cow give me an answer or something like that, right? I can see this, I can see the answer is 23. That's perfectly fine, right? I enjoy and appreciate creativity from students if you want to add bells and whistles and things like that. That's usually all bonus. Just not with assess, because assess is, automated. And it's just something I put together, and it's not very sophisticated about, understanding what it's seeing. The one caveat I will make, though, on being creative in your programming assignments is try to keep in mind that I'm going to be grading 60 assignments. And it might take me 10 or 15 minutes to grade each assignment, especially if there's problems with it, right? So I'm pretty much spending the whole weekend after an assignment going through each person's program and running it, 5 or 10 or 15 times to test different conditions and so on and so forth. So if you do something like, put a big long sleep statement in the beginning of your program, or, pause in between each line of output, or clear the screen, or things like that, that's gonna make it longer for me to grade your code, and I'll probably go in and I'll try to get rid of those features after I've seen them once. So within reason, right? Feel free to be creative and do bells and whistles, and display things in color, or have a talking cow, or whatever, right? And I'm okay with that for the stuff that I'm grading. It's just assess is really particular. All right, so this is a working version of ODP 402, and ODP 403 is almost exactly the same. The difference comes down to something that's called command line arguments. And this is one of these things that's super important going forward. So we're going to talk about this right now, but it's going to come up the rest of the course. And the idea is the following. When we run a program, usually we want to give some information to the program, right? We want to tell it what to do. And there's two fundamentally different ways that we can tell a program what to do. The first is, we run our program, so we type the name of the program and we hit enter. And then the user types some input and we hit enter. And some other stuff happens. Okay, and an example of this is, when we use the BC command. So BC is a calculator program. So I type BC and I hit enter, and it tells me some stuff. And I can type commands. I can say 34 times 9, and it tells me 306. And I can type something else, and it'll give me the answer if I don't make typos. Right? And then when I'm done, I can hit Control-D to exit. So while I'm running this program, it's waiting for me to type information in, and then it's responding to that. And that kind of scenario I'm going to call a runtime input. Runtime means while the program is running. So I said BC to start my program. I didn't tell it anything about what calculations I wanted to do. I just said, run this program. And now I put in some calculations, right? Let's do 2 minus 1, and it tells me it's a 1. Can Bash crash? Yeah, it can. It's pretty rare, but there are ways you could do it. And yeah, let's go ahead and do an attendance ping. I think everybody's here that's coming in. So send me an attendance note. Let me know that you're here. Thanks for the reminder. All right, so command line, runtime inputs we specify while the program's running. There is a second, very, very different way that we can give information to a program, and this is when we type the name of the program, we type a space, and then we put some sort of information on the same line that we're typing the command, and then we hit enter. And this is called a command line input. And throughout this course and the other courses, there'll be times when I'm asking you to write a program that responds to runtime input, and there'll be times when I want you to respond to command line input. So what's an example of command line input? VI. Right? When I want to VI a file, I say VI space, and I type in the name of the file on the command line. I haven't hit enter yet. VI is not started to run yet. I'm at the point where I am typing a command, VI, and I'm typing one or more arguments, file name in this case. And now I hit enter, and the program is running, and it's using that other information that I gave it, the name of the file, to create this file, VI. And these are very different experiences, right? If VI was written with runtime input, how would I edit a file? I would say VI enter. It would say, what program do you want to edit? I would say file name enter, and then it would start editing. If I wanted to compile with runtime input, I would say GCC enter, and it would say, what program do you want to compile? And I'd type the program name enter. And it would say, what do you want to call the output file, etc., right? Really, really conversational behavior. That's not how we GCC a program. We say GCC space -o space main.c space -lm, etc., etc. Put on all this information, and then we hit enter. All right, everybody see the difference between those?
Yep.
And some programs will work with either. So if I say cowsay and I hit enter, it will wait for runtime input. I can say hello, Control D, and it says hello. But I can also use a command line argument. I can say hello from the command line, and it will just go ahead and use that as the input, and it will do its thing. All right, so all of this comes up because ODP 403 is exactly the same as ODP 402, but it's using a command line argument. So the only difference between 403 and 402 is 403 does not say read X, right? 403 takes an argument from the command line, multiplies it by 2, outputs it. So here's what ODP 402 did. It waited for me to type something in after I was running the program, and then it printed out twice that number. Here's what ODP 403 should do. ODP 403, and on the same line that I say ODP 403, I'm going to type a number. Hit enter, it's going to print out twice that number. So the argument is given to the program while you're specifying the program that you want to run. So like that. All right, everybody understand what 403 should do? So how do we get command line arguments in a bash script? It's super, super easy. So there are these variables called $1, $2, and so on. And these are given the value of whatever you type on the command line arguments. So if prog is a bash script, and I say prog space info, inside my bash script, if I look at the value of a variable $1, it's going to be equal to the string info, info. And that's all there is to picking up command line arguments. So let's make a script called try it. And I'm just going to make a single line. I'm going to say echo the argument is, and I'm going to echo the value of $1. Now if I try to run it, I'm going to get an error, permission denied. Make sure you do your change mode instruction. So try it, and I'm going to say try it 66, and it's going to tell me the argument is 66. All right, that's the only difference between ODP 402 and 403. Instead of saying read something from the user, I'm just going to use $1 as the value of that first argument. So if I say try it, ha ha ha, it'll tell me the argument is ha ha ha. If I say try it, this is a test, it's going to tell me the argument is this, because that's the first command line argument. If I wanted the second argument, I could use $2. And if I say try it and I don't give it a first command line argument, $1 is just empty. So I can print out $1, $2, and $3. So this is, that's the values of $1, 2, and 3. If I just try it, misspelled hello, first argument is hello, second and third arguments are blank. And there's other things we can do in here also. So $number will let us figure out how many command line arguments we have. So if I print out the value of $number, if I say try it, this is fun, haha, it'll tell me $number is 4. 1, 2, 3, 4. And if I don't have any arguments, it tells me $number is 0. All right, so that's an easy way to interact with command line arguments, and that's all you need for ODP 403. So any questions on that? All right, so going forward, I want you to use class time and office hours for questions. I'm going to back away from answering programming questions in emails. And in general, when I give you an assignment, like homework 2 I gave out on Wednesday, right? And I said, try to do this today. So if you run into trouble, you can come to office hours Thursday. Okay? So we're going to talk about PA1 next, right? Start PA1 this weekend. Start it today if you have time, so that I don't have hours Monday morning, but by Tuesday morning you can either be done with programming assignment 1, or you can say, hey, I need help with such and such. You can come by office hours and we can talk through it, right? If you don't start PA1 till Thursday, well, office hours are at 8:30 in the morning. The assignment's due at 8 o'clock in the morning Friday, right? And you can't reasonably expect email help Thursday night, particularly if you haven't started the assignment until Thursday afternoon, right? So I really want you to take advantage of office hours and or class time, and feel free to ask questions with any of this work. So let's take a look at PA1. So this is your first sort of larger scale programming assignment. And it's a bash script, and it's going to be a little game. It's a game of picking sticks out of a pile. And the basic setup is this. You have a pile of sticks, and you have 2 players, and you take turns pulling sticks out of the pile. And each turn you can take either 1, 2, or 3 sticks. And the goal is to be the person who takes the last stick. Whoever takes the last stick wins the game. All right, so what does this look like? Let me All right, so your game is called Stick. And how many sticks would you like to play with? 15 or more. So let's play with 19 sticks. And then who should go first? And you get to choose whether you're going to go first or the computer is going to go first. So I'll be polite. I'll let the computer go first. All right. So it says whoever takes the last stick wins. Good luck. Initial pile. And here's a picture of the pile of sticks. So I want to see 19 bars, right? 1 for each stick. And then in parentheses, I want to see the number, so I don't have to count all of these, right? So show me the pile, show me the number of sticks, and then tell me the computer's move. Oh, my computer is cheating. Hold on 1 second. Alright, so how many sticks am I going to play with? 19. I'll let the computer go first. Okay, so there's the initial pile. The computer is going to take 3 sticks. And then it says the remaining pile has 16 sticks. How many sticks should I take? Okay, well, I'll take 3 first. I'll be like a computer. So I took 3. That left 13. And then the computer says I take 1 stick. The remaining pile is 12. How many sticks should I take? Okay, well, I'll take 1 stick too. That left 11. The computer took 3. Now there's 8 sticks. How many sticks should I take? Okay, I'll take 2. The computer took 2 from that pile of 6. Now there's 4 sticks left, and now I'm in trouble. Because whatever I take, 1, 2, or 3, the computer is going to be able to take the last stick. So I'm about to lose. Okay, so I'm going to cheat. I'm going to take 4 sticks. Nope, that's cheating. Try again. Okay, I'll take 1 stick. And the computer takes the remaining 3. The pile is empty. The computer says I win. Alright, that's PA1. So you're going to write a bash script to do this. And you're going to do this in a way that in most cases, unless the user knows what they're doing, the computer is going to win the game. So it's going to use a little algorithm to decide how many sticks to take to maximize its benefit. Alright, so this is all spelled out in the assignment. Your script has to be named Stick, plays the game with an initial number of sticks, take turns picking 1, 2, or 3. Whoever picks the last stick wins. Okay, you run it without any command line arguments. This is all done through runtime inputs. Okay, so you just say stick. Print a greeting, ask the user how many sticks to play with, must be an integer bigger than or equal to 15. Ask who should go first, C or U for computer or user. Okay, if the user makes a mistake in answering these questions, just keep asking. Doesn't matter how many times they mess up. So if I say stick, how many sticks should you play with? I want to play with 1 or 2 or ha ha or I don't know. Keep asking, right? No limit to how many times until the user gives you a valid answer. And then who should go first, user or computer? Me. Well, that's not a valid answer. You. Uppercase U, not a valid answer. Uppercase C, not a valid answer. Right? It's got to be a U or a C. Okay, I'll say user goes first. All right. So those first 2 initial questions, just keep asking until you get valid input. And then show the pile of sticks. Right? A set of pipes in parentheses followed by, or set of pipes followed by the number in parentheses. When it's the user's turn, ask them how many sticks to take, subtract that from the pile, show the pile, and then show the computer's move. If the user tries to make an illegal move, if I say I want to take 16 sticks, that's cheating. Give them one more chance. And if they don't cheat a second time in a row, everything is forgiven. Okay, so here I am again. I'm going to try to take 12 sticks. Hey, that's cheating. Try again. Okay, I'll take 3 sticks. Okay, there's 8 sticks left. How many do you want? Okay, I'm going to take 8. I'm cheating again. If the user cheats 2 times in a row, game's over. They forfeit. But if they cheat once and then they don't cheat on their second try, everything's forgiven. And if later on they cheat once again, you can still give them one more try. Okay, so that's this section in here. How do you decide how many sticks the computer should take? Simple algorithm. Find the number of sticks left in the pile, modulo 4. That's how many sticks the computer takes. So there's a modulo operator in Bash. It's a percent sign, just like C. And if there's 7 sticks left, 7 mod 4 is 3. Take 3 sticks. The one caveat here is if the number of sticks left mod 4 is equal to 0, 0 is not a legal move. So have the computer take exactly 1 stick. Alright, so all of that gives you the exact gameplay that you just saw. Alright, other requirements. It's got to be a bash script. We're going to do this in C for PA2, but for PA1 it's got to be a bash script. Make sure you back up your work as you're going. I suggest pushing into Git as you go. And you need to comment your code. Alright, so I need a block of comments in the beginning. And remember, comments are just something that begins with a number sign. So I want in the very beginning of your file, after the shebang, a block of comments that list your name, the course, CSE224, the date, the assignment, PA1, and then in your own words, a synopsis of the script. What does it do? Right? This can be, 10, 15 lines of text if you want. Enough information so that if you come back to this in 3 years and you want to know what this script did, you can just read the comments you put in and understand what this is all about. And then comment your code as you're writing it. Right? So for example, if you do this business of A equals, n mod 4, if A is equal to 0, A equals 1, what's that about? Put some comments in your code, right? And explain why you're doing those things. Why are you taking the number of sticks mod 4? Why are you setting your number of sticks to take equal to 1 if that was equal to 0? And so on and so forth. This will help me in looking at your code if we're looking for partial credit. This will help you when you're writing your code to understand what you're doing and be clear on it. And it will help you when you're debugging your code. If something's supposed to be happening and you look at your comments and you say, oh, that's not what I'm doing here, right? Your debugging is really easy. So a lot of our effort in this course, the whole sequence of courses, is going to be getting good habits about commenting code as you write. And I know most people go in at the end, right when they're ready to submit their code, and they add all their comments at that point. And I'm going to ask you not to do that for a few reasons. One, it defeats the whole idea of commenting your code. And two, I always have students who break their code when they do that. They go in and they add some comments at the last minute and then submit it, and they don't retest their code. And you know what? They've changed something in their program by putting in a comment, and their program doesn't work. So try to get in the habit of commenting as you go. And then submission, under your CSE224 repository, make a subdirectory named PA1, do all your work in there, and make sure you push it to GitLab. And if you're pushing it along the way, you don't have to remember to push it, Friday morning or something. All right, any questions on the goals of PA1? All right, so you've got a lot of what you need to do this already. You know how to read, you know how to echo, you know how to do arithmetic. But you still need to be able to do loops and conditional statements. And I'm going to point you largely to, on Canvas, there's a, Bash how-to summary of bash ifs, loops, and arithmetic. This is going to be your main resource you want to use over the next few days. This will tell you everything you need to know about how to do loops and conditionals in the way that I need you to do them in this course. Okay, and we may have a bit of time to do some of this in class today. We'll mostly do this on Monday, but let me talk you through the gist of this. So if you want to do a loop, right, the keyword is while, space, bracket, bracket with no space, space, some condition, space, bracket, bracket with no space. And all of those spaces or non-spaces are super critical. If I put a space between these brackets, nothing works. If I forget this space right here, it's not going to work, right? So while, space, all of that stuff, and I've emphasized the spaces by putting in lots of spaces. Next line, DO. Next line's the things you want to have happen inside your loop. And next line, the keyword done. And this will perform all of these statements until this condition is no longer true. All right, so what conditions can we put in? Well, there's two types of conditions. We can compare strings, right, literal sequences of characters, or we can compare numbers. So to compare strings, we use a double equal sign. For equal, we use exclamation mark equal for not equal. So while bracket bracket something equals equals something else. To compare numbers, we use -EQ, -NE, -GT for equal, not equal, greater than or equal, less than or equal. So quick example.
I have a question.
Mm-hmm.
In 270, when we're dealing with assembly, you make while loops out of the jump to command.
Mm-hmm.
Do other languages have an equivalent to the jump to command without directly being a while loop? Like I could call a check, and if that check is true, jump to this line or something?
So C actually has a go-to statement, which is like a jump in assembly. Java, I don't actually remember if Java has a go-to or not. One other modern language actually does have a go-to still. But we kind of need to avoid go-tos, not because they're actually evil, but because people think they're evil. And if you're, writing code for a job interview, for example, and you use a go-to, chances are you're going to not get the job. Unless it's a really cool company and you're talking to someone really cool and they think you're deliberately being controversial. So yeah, those things exist. And a while statement here turns into a go-to somewhere, right? The assembly language is doing something like a jump or a go-to, but we usually avoid them and try to use while statements or for loops. We're not going to use for loops in Bash, though. We're going to stick with whiles. So here's a simple while loop.
Will it be graded down if we use a semicolon and then do right after the while instead of line?
I won't grade you down, but it will disturb me a little bit. I would prefer you do it like this, only because this is always the way that I'm going to write these things. This is always the way you're going to see things. But there's nothing wrong with doing a semicolon and putting the do on the next line. As long as if you encounter this, it's not going to trip you up. Okay? But I will be super picky about, the space and the double brackets and the space and so on and so forth. But if I type this on the command line and I command line recall it, it'll do a semicolon. So yeah, that's okay. You can do that. Just make sure this doesn't trip you up. All right, so I'm going to set x equal to 10. I'm going to say while x is not equal to 0, do. I'm going to echo x. I'm going to set x equal to x minus 1. This should print out, a set of numbers from 10 down to 1. Right, so there you go. That's a basic loop. And then an if statement is if space, bracket, bracket, space, condition, space, bracket, bracket, new line, then, or semicolon, then. Statements of your if, and then phi is the closing bracket for the if statement. It ends the if statement. So if this was C, then would be a curly bracket, and phi would be a closing curly bracket. But instead of saying phi, we could say else, and we could list a condition, things to do if the condition is false, or we could list another else statement by saying elif. Okay, this is only bash. This does not work in C. But for bash, this is how we can do conditionals. So I could throw a conditional in here, and I'll throw some comments in here. This is a loop demo. Do this 10 times. And I'll put a comment here saying that I'm counting down. But I'm going to do something else here. If $x equals 5, then I like the number 5. And my comment here is be weird. Alright, so I've got a while loop, and inside that while loop I've got an if statement which says, hey, if x is equal to 5, then let's go ahead and print this out.
And real quick, like C, can you put, I mean, you can put the x equals x minus 1 in that if, right? And then else would be like something else if it doesn't meet the condition.
You could if you do it right, but it's not quite as flexible as C. Yeah, I mean, I could do the x equals x minus 1 in here, if that's what you mean.
Yeah, just so that way if it meets the condition, then it does the x minus 1. Otherwise, it goes back
Yeah,
to
that's
the loop without changing.
that's fine. I'm not going to do an attendance ping at the end either, so if you have to run off to physics, feel free, because I know there's a Friday physics at 5, at 12. So I'm not going to do another attendance. So if I run this, right, it counts down, and when it gets to 5, it says I like the number 5. So this is more junk code, right? This is just code to play around with bash syntax. But my suggestion is spend some time working with this, right? Write yourself a lot of sample scripts like this that use while, use different versions of conditionals, use some ifs, do an if then, do an if then else, and so on and so forth, so that you're comfortable with these mechanics, right? And then when you start writing PA1, if something's not working, you're not worried about, am I using my if statement wrong, right? Because you've got code you can go back to that you've written and tested and refer to know how to do conditionals and loops and so on. So play around with that, and maybe I'll push this over to the server as just like a sample of some bash conditionals and loops.
What if x were a string? Would there be any problems with using not equals?
Yeah, so if x is a string and I try to use not equals, if I do a string and compare it to a number, it's treated like a 0. So this condition would actually be true, would actually be false, right? If x was hello, it would change that into a 0, and it would kick out of my while loop right away. But I could do something like this. So I could say, you know, let's read a line from the user, and if it's not equal to bye, then I'll say bye, and I'll read another line from the user, and this will just keep looping until the user says bye. So I'll say hello, it'll say bye, and when I finally say bye, it'll say goodbye. So I'll push those over to the server in that shared code area as just some example code to work with. All right, so we're done here. I will see you in 2:15 at 12:30, or I will see you Monday if you're not in 2:15. Have a good one. Take care, and I'll see you next time.
Thanks.
Have a good one.
On PA1, are we doing any checking to make sure that the things we enter are